Hello my friends, my name is Irvin, also known as Koboman. In today's video, we're going to talk about three different videos, three different topics for desktop support, and if you're also learning help desk. Very useful stuff. The first one is about ping command, how to use ping command and how to resolve issues using it. Second one is about traceroute. Ever heard about TRACERT command? Well, I'm going to talk about it and we're going to learn about it. Very cool and interesting stuff. Last thing we're going to talk about is reliability monitor. A lot of people don't know about it, but reliability monitor is kind of like software, but it's actually built into Windows. I know it's actually software, but it's part of Windows. And we're going to learn about it because it's kind of cool and not many people know about it. And it can help you resolve weird computer issues that are kind of apparent and easy to actually visualize using Reliability Monitor. It really tells you what's going on. All right, guys, let's check it out. But before we do that, please take 1 second to like this video. It really makes a big difference to me and my channel. It really helps me grow and whatnot. Thank you so much. I really appreciate you doing that. So if you're doing tech support or desktop support or what have you, chances are you'll be using ping command. So what is ping command and its use? I'm going to talk about the first part of it and explain the whole thing, but my written answer here is generally the ping command is used to determine whether your computer has access to external resources or the internet. So anything that is considered external resources is anything that's outside of the connection of your computer. So let's say you're using a desktop PC at work or a laptop, and then you're trying to access an external resource like a shared drive or a server or a website, whether it's internal or external, and you can't connect to it, or there's a issue with latency or lag of some sort, it's running slow. That's how ping command would be used, and all these things are considered as external resources, so something that your computer connects to over the network. Okay, now through command prompt CMD you can type in, for example, ping www.microsoft.com, and this is an example of a ping command. So let's go ahead and open up CMD. I'm going to open up command line, command prompt, or whatever you call it. I keep saying command prompt, command line. I use Linux too, so sometimes I forget which one is which. Anyways, we're going to use this example that we have here, and it's ping www.microsoft.com. So let's see what happens when a normal working website is up and running and see the result from it. Did I misspell that? Of course I did. Microsoft.com. I'm trying to multitask here, so you will forgive me. Okay, so one of the first things that comes up that you will notice here is a number, which is an IP address, which is controlled by the DNS. And the DNS, basically what it does is takes a domain name, in this case Microsoft.com, and translates it into an IP address, which is the location of this website on a server. So the server for Microsoft.com is located at 23.45.133.21. So that's the IP address for the server for Microsoft.com. Okay, so now these are results of the ping command for a normal running website that is up and running and there are no problems. So what happens is ping command sends 4 packets of data. So you can see here that it sent 4 packets. They are size of 32 bytes. And then it waits for a response and how long it takes to respond, which is shown here in milliseconds. So this is the first attempt from of the ping to this IP address. And we can see that the response time here, that it took 14 milliseconds to respond. And then the ping command does it again, which is the second time, and this time it replied in 15 milliseconds. And then the third time, also 15 milliseconds. And then fourth time, also 15 milliseconds. Hence, 4 packets sent. Right? Very, very easy to understand. But of course, for it to actually respond, for actually to have a response of any sort, it has to send back 4 packets as well. So you can see here that the server at 2345.133.21 also sent back 4 packets which were received at the same size. And then we can see that lost 0, that means it was successful. That means none of the packets failed, that all the 4 pings were successful. That's an example of successful ping command. We know everything is okay with this website. So let's go find a website that doesn't work. So I went to this website, and this website kind of tells you of some of the big websites that are down. So let's kind of pick a random one here. Let's pick Trivago.com here. That's a safe website. We're going to type in ping Trivago. Well, let's do www.trivago.com. Now, if this website is down, like it says it is, we're going to get some negative results, which would be a good example of of how you use a ping command and how to help you troubleshoot the issues. So far, we can see that it's timing out. What does that mean? That the first packet was sent and it didn't connect. It waited a certain amount of time, didn't connect to the server, or the server didn't reply, I should say, and then it timed out. And then the second time as well, I'm sorry, first time, second time, and we're waiting for the third one. Third one timed out. I'm sorry, I didn't mean to go all full screen here. Let me kind of move some of this stuff out of the way so it's easier to see. And we can see that all 4 packets sent timed out. That means that the server just, the ping, waited, we waited and the server didn't respond, timeout. There's only a certain amount of time ping command will wait for a response. And that's what happened. And we can again see here that 4 packets are sent. And then 0 received. And in this example, Trivago.com is located at this IP address. That's the server, that's the web server for the Trivago.com. And now we can see that we sent 4, we waited, nothing happened, we received 0 because it's down. And then we lost 4. That means we sent 4 and they never came back, which gives us 100% loss of packets. So how does this help us? Well, for one thing, we know the website is down, or a server that you're trying to access at your job is down, right? We can, web server or some other network component, some other network resources. If you have the name for it or the IP address, you can just ping the IP address. If you wanted to, you can just type in ping, IP address 35179.002.200. And here we go again. We're pinging Trivago's server again, except we're just directly bypassing the domain name. We're bypassing the we're not necessarily bypassing but we're bypassing the domain name. We're going directly to pinging the server itself. And again, it's timing out, which is another indicator that the website is down. So going back to the my question of how does this help us aside from knowing that the website is down? So if it's an external website, what we would have to do is find the webmaster for it, or a person who has access to the server. Same thing goes for if it's internal website. So let's say your business, or the business that you work for, has some kind of internal website that everybody goes to, everybody uses it, this and that, and you don't have necessarily access to it. You would find that webmaster and contact them. So how would you go about that? Well, if you know who the owner of Trivago.com is, you would contact them directly, obviously. But if you don't know who the owner is, based off the name of the Trivago.com, based off the domain name, you can see who the owner is of this IP address. And this is something that your company would provide this to you if you're doing tech support. So you would basically have a tool that lets you tool, or some kind of notes or something. I don't know. This all depends on, this varies from place to place, But for example, at my main job, I will know who owns this IP address. So not only can I look up to see who owns Trivago.com, for example, I can also look up who owns this IP address, and then I would contact that guy who is the owner of this IP address, or a guy or a gal or whatever. I would contact them and say, hey, this website is down. But the only time I would do that is if I don't have direct access to this. So let's say this is a server that I have, that I'm running, and everybody in the business here is using it as just a storage location. Let's say this is just a web server that hosts files for everybody in my building that I support. Well, I would simply just try this. If I don't have physical access to it, I would open up remote desktop connection, type in 8.35.179.200. See if I can connect to it. And it's going to fail because obviously I don't have access to it. And, that's okay. But if I have physical access to it and I know where it's located in the data center or in a server room or whatever it is, chances are this server might be just turned off, or, there might be something else bad with it. But at least I will know that there is something wrong going on by using the ping command, and that will get me to either me fixing it or finding who can fix it. And that's how you would use ping command in a business environment. Either way, for this, we're going to need a command line, which we're going to open up right now. So in order to use traceroute, we're basically going to use the example from the article. It's simply typed in TRACERT, pardon me, TRACERT, followed by the name of the website you're trying to reach. This doesn't have to be a website. It could be a server of some sort, or a switch, or I should say just an IP address of a network component or a location. So, and that gets me into why would you want to use TRACERT. Before I even hit enter here and then a bunch of stuff comes up, I want you to understand why you would want to use it. So let's say at your work, at your office, for some reason you cannot reach cosmicnovo.com. However, from your phone, which is, by the way, on a network, on a different network entirely, you can reach Cosmic Novo just fine. Also, another example is an application that uses network connection to work. For example, an application that has to reach to a database that could be located in totally different state, country, this and that. It could be at the end of the world. It could be that it's not working. That's another reason you would want to use Traceroute. Or simply there is a server somewhere we can't reach, whether it's used for storage or this and that. We would want to use Traceroute to figure out why you can't reach it from your office network, but you can reach it from any other network. So what it does in the nutshell, Traceroute, it traces all the routes taken on the network to reach cosmicnovo.com in this example. So it's going to map it out for me. So think about it this way. Let's say you have a date, or you are going somewhere that you've never been before. You open up your phone, you go to Google or Apple or whatever it is that you're using, you type in your navigation the address that you want to visit. And it gives you all these routes that it takes. It says go straight, go left, go right, this and that. The Traceroute kind of does the same thing in a sense. However, Traceroute, it will tell you whether there are certain roads or routes that you cannot take, or that they're broken or non-existent. So that's a very simple explanation of what Traceroute does. It tells you whether a certain turn is broken or non-existent. Hence the name Traceroute. I hope that's an easy one to understand there. So we're going to see an example of this. As soon as I hit enter here, we're going to see what happens, and I'm going to explain all the steps that it's going through. All right, hitting enter. With Traceroute executed, this is typically what happens. It takes maximum of 30 hops, as in 30 roads or 30 paths, if you will, in order to reach the final destination, which is this IP address for this website. And this may take a while. This is why I have a finished trace route of all the routes taken for that website, and I will show you what that is right now. So let's have a look at some of the things that kind of stand out. The first hop that shows up is basically pinging my IP address of the local computer. So the computer I'm using right now, local IP address for that is 192.168.1.1. So that's a typical local IP address. Second hop is basically trying to ping my IP address, external IP address for the internet. So my internet provider, which is Charter, is actually blocking that information for security reasons. It automatically blocks it. There's nothing I can do about it, but it's perfectly normal to see a second hop fail timeout like this. And then you can see that hops 3 through 8 are all from my internet provider. Charter.com Charter is my internet provider, and you can see all these, if you will, switches that it takes in order to access the internet that goes outside of the Charter's network. So it goes through all of these, and it seems everything seems fine, so that's perfectly fine. And then finally reaches the internet, and then it has to go through this switch here. And again, it looks normal. This route is normal. And then it goes to the number 10. Again, it's normal. Then we look at 11, and we can see that there's increased millisecond response. Not necessarily too bad, because we're not talking like 80 milliseconds, 100 plus or something like that. However, something does stand out here, and that there is a third, on the third response or third attempt ping of it, there is no response whatsoever. It timed out. So if we are having issues connecting to the final destination, potentially we could look at the switches or servers that are located at these two IP addresses. So the first one is 72.1.232.70, and this other one that starts with 172. So because we see no response here at all for the third ping there, we can kind of possibly assume that there might be some kind of a latency issue with these two switches or nodes, if you will, or they could be server or whatever it is that they are. We can look at that, because it could be a server somewhere. And the reason I say server is, in a sense, depending on which type of thing are we troubleshooting. Are we troubleshooting a website, or are we troubleshooting application connection, this and that? So it could be a part of the final destination of, like, for example, application that maybe uses some kind of database that is located at this server or whatnot, or server itself could be the firewall. We don't know, but we need to know kind of what's causing this delay or lack of response whatsoever, if there is a problem, right? But typically that's associated with higher millisecond response time. So in our case, this is probably just normal, and chances are that these servers here just have a limit of how many times you can ping it. So we're going to move on from that, and then it goes through a bunch of different nodes here, which could mean that it's just blocking. This is very typical, that these nodes are literally just blocking these type of connection requests, which is fine. This is pretty normal, but every time you see a gap in between where it fails somewhere, this is something we would have to be concerned about. And we'll potentially look at that here in a moment, but this is an example of a good traceroute response. And then finally reaches the destination of 130.211.160.109, which is where cosmicnovo.com is located, as you can see here. So it took all the routes, and it took it 23 routes to get to the final destination, and we know that everything is okay here. All right, so I found a website that's supposed to be down, a safe website, and let's see, do I have that going here? Yep, I had it tested. It's Anthem.com, which is basically an insurance provider, health insurance provider, and I saw that it's down. Let me just double check here one more time. We're going to ping it one more time to to make sure that it's down. And then we're going to do a trace route on it to see if we can figure out what's causing the problem. Chances are it's the web server itself, but it could be something in between too. So I'm going to do a trace route on that as well. And then I'm going to, and you can see that it failed. You know, sent 4, received 0. It's timing out, definitely down. So we're going to do a trace route, rt anthem.com, and see what kind of response we can get. Again, this may take a while, which I will just fast forward to the results so we can see what's going on with that. So as we are looking at the results of Anthem.com, you can see that they are similar to what we had earlier in the sense that it's taking same routes initially. And this kind of goes back to what I was talking about. See, this is the first one, and we can tell that it takes, hits my LAN, and then it goes through all of these charter switches, if you will. And if we go back here, we can see that they are the same switches, and it takes that same route. However, after it hits those, it decides to go another way, which was dictated by this switch. This switch says, okay, well, now you're done with the charter network. Now you have to go through this something else. So let's look at the previous one. I'm sorry. Let's look at the previous one here. And did we take the same 15166? So in our case, after the 166, charter sent us to this other one, which ends with 12, which, by the way, is probably next to it. So there is a switch probably next to it in the same data center. You can see how it's only off by 3 IP addresses. Anyways, it decided, in this case, for the Anthem.com, which is this top one, it decided to bypass the next switch, which typically would have been this one, to route to cosmicnova.com. It had to take another one here. So instead of going to any of these other ones, you can see that this one just said, okay, well, this is going somewhere else. And it takes a different route, and it goes to this other, probably internet provider of some sort, which I'm assuming is related to AT&T. And it doesn't say that here, but the reason I know is if you look at these 7 through 10, you can see that the switches names are STL, which stands for St. Louis. ORD probably stands for Orlando, Florida. And you can see that they're called atlas.cogento.com. And you can see the IP address that are connected to there. However, if you look at number 10, you can see that it says ATT here, so which is AT&T, probably Orlando. So it goes through Florida somewhere, and then it continues with switches that are located or that belong to AT&T, and then routes it further. And you can see that it hits another 3 gateways, most likely on an AT&T server before it reaches its final destination. This is still taking forever, so once it's finished, I'll show you what the end result is for Anthem.com. However, I want to talk about a point of failure that may occur, that may show up in Traceroute command. And here's a really good example. We can look at these AT&T switches here. So 11 through 13. Traceroute can tell you immediately whether something failed and in the path that it's taking. So we can imagine that in this example that number 12 here timed out. So let's pretend this one timed out, literally timed out, and we need to figure out where is it at, what's wrong with this. Chances are if it timed out that either it's blocking this type of information from being sent back, which happens with my IP address here. But however, if it's just kind of in the middle here, and we know kind of by intuition that it's supposed to take another route because it goes to the third one here, but for some reason this one in the middle times out, that's a clear indicator of a switch that is, or the switch that is just bad. So how do we find out, if it's bad or not? Well, we would have to reach out to this guy or this company and ask them, okay, well, we need to get somebody from AT&T on the call, or call them or contact them and say, hey, there's a problem here. And they'll be like, okay, well, let's send me the results of Traceroute from your location. And they send it, you send it to them, and then suddenly they're like, oh, the number 12 failed, but we still know it's kind of on their network because it keeps going to their network. You see what I'm saying? It goes to AT&T. We know all three of these hops are going to be AT&T, but the middle one fails. That means it's still on their network, and the problem is on their network, and they need to look at this. And they would know. I know it would say timed out here, but they would know what the next one would be or should be, or whether there is a break of some sort that prevents everybody, and that one switch is causing the problem. So they would look at this and they say, okay, well, we know it's on this network. Let's scour our network and look for this broken switch. And that's the point of Traceroute. Of course, there could be other examples of that, and that is, let's say this one doesn't time out, but there's a huge latency issue here. That would also be indicated by Traceroute that there is a problem. So let's say the response time is like 100 milliseconds or even 80 milliseconds. This causes connection timeouts on the application end or a user end as well. So let's say there's a huge latency here. There's another reason why they would want to look at that switch or server and kind of see what's going on. The reason I say server is because it could be the final destination. We don't know. But in our case, we know it's not. It's just a switch that it's taking. And then with the traceroute information, we can forward this information to them and say, okay, well, this is probably what's going on. Now this thing is going to time out, and I'm going to kind of tell it to skip by hitting enter the attempt. For some reason, it gets stuck like this, waiting to get a response from the switch. And then I'm going to fast forward this to the end result. So as the final result of the traceroute is coming up, we can see that the Anthem.com is just simply down. This is what it tells us. The normal response from the traceroute when everything's okay is indicated in my other window here. And you can see that the final hop gives us the final destination address. In our case of Anthem.com, it doesn't. It never reaches it, and this is clear indication that there's something wrong at the web server level. So the webmaster for Anthem.com needs to look at it and resolve the issue at the server level. So, but when we know that the website is down for everybody, this is not necessarily the reason we would use traceroute.com or traceroute command for. We would simply just use ping command to see if it's up or down. But if there is an issue of latency, if there is an issue of website or an application working for some people but not others that are on a different network, that's when we would use the traceroute. So it's for troubleshooting connection issues that are specific to a network, meaning that just because I can reach it doesn't mean that some other people can as well. So this is how you would use traceroute to figure out where is the breaking point on their end and why can't they reach, or why can't I reach a certain web server, application server, or what not. And in today's video, we're going to talk about Reliability Monitor. It's one of those tools that comes with Windows 10 that people don't really talk about or mention, but it's actually a really cool monitor that kind of filters everything out for you when it comes to system issues or system events. So it's similar to Event Viewer, except it's a little bit easier to follow, a little bit easier to navigate through. And I'll show you exactly what I mean. So let's go ahead and pull up Reliability Monitor. You can simply search for it and just type in Reliability Monitor, and what comes up is View Reliability History. Alternative way to get into it is through Control Panel. If you go to Control Panel, select Security Maintenance here, and then expand maintenance, and then from here we need to click on View Reliability History. We're going to click on that, and now it expands our reliability monitor once more. So what is, again, reliability monitor? You can think of reliability monitor, for example, as a highly filtered version of Event Viewer. So instead of giving you all the details for that one day on your computer, it gives you kind of filtered version of it that's much easier to follow, and it kind of mostly points out software updates and critical issues that may happen on your computer. It lists successful and failed software and driver installations, as well crashes, apps, and programs that stopped responding, and other errors, of course, on a time-based scale. So what does that mean? That means it shows you events for every viewer, every day, I'm sorry, just like Event Viewer, except it's a lot more simplified, and it gives you this kind of a graph with dates aligned as this. You can see the only main thing that keep in mind is that Reliability Monitor only goes back as far as 1 month. So it only gives you 1 month of event viewing when it comes to issues on your computer, which could be good enough to kind of troubleshoot all the computer issues that are happening. So you don't necessarily need to go back over a month ago to figure out what is going on right now with your computer. On top of that, Reliability Monitor, it can often provide important clues about the cause of sudden changes in system behavior as well, and that can be determined by the events that happened. And it can also kind of give you an idea why, for example, my computer is crashing, what happened with the application, why did it stop, this and that. So again, it's an event viewer in a sense, except it's a lot more user friendly, if you will, or IT support friendly. So with the Reliability Monitor, let's go ahead and look at an example. And here's a good one. It says here that on October 5th, 2019, something happened. So if we just click on this bar, we can see that it gives you the details as well, but it also points out a critical event with this circle, with a red circle with the X in it, and then we have the warning one, exclamation mark here, which is in yellow, and then we have regular event here, which is in blue. So let's look at the first critical event. It says Windows was not properly shut down, and you can see how it's easily laid out for you, and it gives you the date here, and it says, it's October 5th at 8 a.m. And then, of course, on the right-hand side of it, you can click on View Technical Details, which will give you more information on it if you select that. So you can imagine, let's say your computer is unstable and says, your computer is shutting down just randomly. Windows was not properly shut down. So what does that mean? It means that either somebody pulled the plug, the power went out, or something caused the crash. So let's go ahead and click on View Technical Details, and expands it, and it gives you a little bit more information. But as far as the computer knows, it just knows that Windows was not properly shut down. So this could mean literally that it lost power. And then it also in description it says the previous system shutdown on let's see, what is this, 6 days ago was unexpected. So it gives you an idea that, hey, this happened also 5 days ago. So that can give you a clue of what might be happening. So you can either ask the user, hey, do you remember it shutting down before? Or you can simply confirm what the user is saying, hey, this happened before. And then you can look at it, you can say, hey, did this happen about 5 days ago? And then you can see that there's a pattern going on here. So very similar to Event Viewer. And of course, I have a video on Event Viewer if you want to check that out. I'll toss a link on the right-hand side here. So let's look at the exclamation one, that it's just a warning, and it says here Google Update Helper, and it says unsuccessful application reconfiguration, and it happened on the same day at 8:08 a.m. So let's say somebody's complaining about Google Chrome, for example, because Google Chrome is the only product I have on this computer. And of course, it's going to have a Google Update Helper. And then I can see, well, all right, well, something's going on here. And then obviously it says here unsuccessful application reconfiguration. So I'm going to click on view technical details, and it's going to give me a little bit more of the information. And again, it kind of repeats what it said earlier here and on the top. And then in the description, it says Windows installer reconfigured the product, and it gives you the product name, and that is Google Update Helper, and it gives you product version, product language, manufacturer, Google LLC, and then it gives you reconfiguration success or error status. So at this point, we don't know what happened, because if it says unsuccessful application reconfiguration, as far as we know, it could be just permission issues. But at least we have an error status, which is the error code 1638. So we can simply Google this and find out on the internet what this error actually means. But again, it could be just simple permissions issue, and if user is complaining about Google not working properly, Google Chrome or this and that, this kind of gives you a clue, at least a starting point. So let's just look at some of the blue events that happened, and informational events are down here. And then again, you can see there is another Google Update Helper, and then it says here successful application reconfiguration, and it happened kind of exact same time where it unsuccessfully did it. So that means most likely that it did get its permissions that it needed to do so, and then it actually did it. So we can kind of confirm here that was successful, and we can see that the error status is 0. So right away we can see, well, that's not the problem. Just because it failed here, it actually succeeded below here. So we're done with the Google issue here. And then of course we just have a regular event, and it says here cumulative update for .NET framework for Windows 10, and it says successful Windows update. So generally speaking, informational events are just that. It gives you information that something usually just happen normally, and that is also good to know, so that way we can kind of exclude those things as possible problems for this PC. So with this tool, we can just keep going and scrolling through all the events. You can see some of them are just blank. There is basically just means there's no issues on those days. And then we got, again, just the blue event that happened, and it's just normal. But the ones we want to kind of concentrate on here are the ones that are critical events. For example, this setup host.exe stopped responding on October 13th at 8:53 a.m. And then we can just keep going and kind of look at those issues and see what happened, and it kind of gives you a really good starting point when it comes to figuring out what is wrong with all of these computer issues that may be happening. And sure, I can go through all this stuff together with you, and let's just go ahead and take a quick look. This one looks a little bit different because it's a setup host.exe, and it says again stop responding at 8:53 a.m. and it gives you quite a bit more detail, and this is going to vary from program to program, of course. But again, it gives you starting place to help you troubleshoot what the issue is. And for example, this one says stopped interacting with Windows and it was closed. To see more information about the problem, check the problem history in the security maintenance control panel. So it gives you another starting point here. It also gives you application path in some cases, and you can see where this program is located, and this is a Windows component. And then let's look at the something similar, and it says for this yellow exclamation mark right underneath it, it says Notepad++, unsuccessful application installation. And we can see more details of this one as well. Again, this one happened on 8:51 a.m. and it says Windows install the product, blah, 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 and then installation success or error status. So this is most likely a failed installation, and then we can look up again what the error is to clarify that information. Well, there you have it, guys. This is a very useful tool in my opinion if you don't want to look all the information in the event viewer, if you find that confusing, because I can see how event viewer could be harder to navigate through, especially for new people to tech support. So hey, if you get an issue from a user or a user reports an issue, it says, hey, my computer's unstable, I don't know what's going on. Reliability monitor is a good place to start to give you a quick look to see what's going on with that PC. All right, I hope you like this video. Please share it with friends. If you have any questions, please let me know. Leave any likes, and I will see you next time. Thank you for watching. Have a good day. Bye-bye.